All right, here we go. So we are trying to find the center of mass of this thing. This is problem number 5 from chapter 9 of the Halliday and Resnick textbook. So what I'm going to do is I'm going to split it up into two parts. All right, so the first thing we're going to do is we're going to find along the x dimension, we're going to find what our center of mass is. All right. So in order to do this, we're going to break this thing up into chunks. And I think you can kind of see it's already sort of divided up into 4 little chunks. All right, so let's give those chunks names. Let's call this chunk over here in the first quadrant, we'll call that chunk A. Over here in the second quadrant, we'll call that chunk B, chunk C, and chunk D. Okay? Now notice the mass is proportional to the area, right? So let's just pick arbitrary units of mass. And so with those arbitrary units, I know that chunk A is going to have a mass of 4 mass units, right? Because the area is 4L squared, right? The mass of chunk B is going to be, 2L times 3L, so 6L squared. The mass of chunk C is going to be 4L times 2L, so 8 mass units, and this will be 4 also. Okay, so all I'm going to do is I'm going to treat each of these chunks as a particle located at its center of mass. Okay, so to find my x center of mass, here's what I'm going to do. I'm going to take the mass of chunk A, which is 4 mass units, times the x position of its center of mass. So if this is 4, its center would be at 2, right? So 2L, right? Okay. Plus, chunk B has a mass of 6 units, and its center of mass is over here at -1, right? On the x-axis. So -1L. Plus, chunk C has a mass of 8 units, and its center of mass is the same, x-wise, it's at the same position as chunk B, -1L. And finally, chunk C has a mass of 4 units, and its center of mass is at 1L. All right, and then I'm going to take this whole thing and divide it by my total mass, which is 4 plus 6 plus 8 plus 4 is 22 mass units. Okay, so let's see, what are we going to get? We're going to have 8L minus 6L minus 8L plus 4L, 4L, all over 22. So what are we going to get? Looks like -2L over 22. So L is 5, so we're looking at -10 over 22 centimeters. So 10 divided by 22 gives us 0.45 centimeters negative style, right? Okay, so there's our x center of mass. And now I'm just going to repeat the same process for my y center of mass. Okay, so my y center of mass, well, let's see. The mass of chunk A is 4. Its vertical center of mass is up here. So let's see, it looks like this is 2L plus another half. So 2 1/2 L. Plus chunk B has a mass of 6. Its center of mass is going to be halfway through 3L, so that's 1.5 L. Plus, let's see, chunk D has a mass of, or sorry, chunk C has a mass of 8 units. Its center of mass is going to be at half of 4L, but it's a negative, right? Because it's below the x-axis now. So -2L. And then chunk D has a mass of 4. Its center of mass is going to be at 2 plus 1, so -3L. All over our total mass of 22 units. So let's see, we're looking at 4 times 2.5 is 10L, plus 6 times 1.5 is 9L, minus 16L, minus 12L, all over 22. So let's see, 19 minus 28 is what, -9? So you get -9L over 22. This thing is in my way. So that's -45 over 22 centimeters. 45 divided by 22 gives us 2.05, so I guess we should just call it 2.0 centimeters. We're keeping track of our sig figs, and that did turn out to be negative, didn't it? All right, so there you go. So our center of mass for this particle is at the position -0.45 centimeters, comma, 2.0 centimeters. There you go, final answer.